some odd looking pictures, a bit of background info, just to make sure, Ashley Keelan every time, please, please. It's just really off-putting. Why am I showing a picture of a train line? Just want to make sure that we're all aware, and most of us probably are, fine. What's a metre? Okay, there's about 1.5 metres between train lines. Here's a metre. Roughly a 6-foot mile is about 1.8 metres. So we start doing with metres. And the SI system, System International, it's around that way because the French came up with it. And most of us, well, Australia uses the SI units, in other words, the metric system. America uses the imperial system, so they're still pounds, feet, all that stuff, yards, inches. Well, our length is metre. There's just a really early thing in France, just showing it was on the street, a way that people could find out how long's a metre. They'd have these on the street they could go to and work out what this new length was. Initially, it's pretty large scale. They defined a metre as that. Because, I mean, who was it decided a metre's that long? Why not that? Why not that? Well, they decided to be 1/10,000,000th of the distance from the geographic North Pole to the equator passing through Paris. So not that handy, but they needed some sort of, okay, what's a metre? That's a metre. That seems like you could still get accurate on that, but it wasn't accurate enough. This is still background info. We're not asking you, you know, where did the line pass through? What fraction of that distance was a metre? It's just where did it come from? Then they made this metal bar, an exact metre long, or exact, I mean, how exact can it be? 1.0000 metres. We've got limits how exact we can go in anything. And we'll do that when we get to errors. We'll see that nothing's really exact that we make in real life. But anyway, they made it. They keep it at 0 degrees Celsius because metal changes length, expands and contracts in different temperatures. Up until 1960, that was the standard metre. And people from unis could go along and take their standard rule, go in there and mark off, you know, as precise as they could. Here's a metre. They've redefined it to that, which seems really bizarre. But that doesn't change. It's a very complicated definition. But the distance travelled by a ray of electromagnetic energy through a vacuum in that approximately 1/3,000,000th of a second just never changes. So that's now what a metre is defined as. Kilogram. Those pictures, once again, are just to get the concept, you know, how big's a gram? A paperclip is almost exactly a gram. A kilo of sugar, well, surprisingly weighs a kilo. That model of car was almost exactly a tonne. Once again, trivia. But there's a concept. When we're talking about these things, we want to visualise it. This is all to avoid answers of you know, how much did that car weigh, and you end up with an answer of 6 tonnes, and you're going, hopefully you'll say, oh, that doesn't sound good. 6-tonne car, no. Truck, maybe. So let's try and get some realism into it. This, talking about weight, the gram was defined as, and is still equal to, 1 centimetre cubed of water. So just imagine 1 by 1 by 1, this tiny little centimetre cube, fill that with water, that's a millilitre. And that's still the case. A mil and a centimetre cubed, same thing. They moved to this kilo. Once again, they put in France, put in a controlled atmosphere. That was about the golf ball size. That's a kilo that they had as a standard. And as for the technical standard they moved to, they haven't moved to it yet. They're still having meetings about what is just never, ever, ever going to change as a definition for a kilo. So they get right into it. A second, you'll think, and I had thought, a second is just, well, really transparent. There's 60 seconds in a minute, 60 minutes in an hour, it's 86,400 seconds in a day. You'll think, well, that's just lock it in. But our days aren't the same length. It seems like they would be exactly a day, but between the opposite 6 months, there's about 13 seconds difference in the length of a day. So that's their new definition. Once again, very technical, and be honest, but that's what a second's defined at. So they're the main three we're going to be looking at. Okay, there's all the SI units, but we care about length, mass, and time. For interest's sake, there are 4 others, which if you're doing in chemistry or doing physics next semester, well, electric current in amps, thermodynamic temperature is in just temperature, Kelvin, which is very similar to Celsius. amount of substance, so many moles of something in chemistry, and luminous intensity, candela, basically brightness. But the top three is what we care about. Notice the oddity in the top three is the kilograms. It's the only SI unit that has a prefix on it. By prefix, I mean it's really grams, okay? But they've got a kilo next to it. They don't have kilometers or kiloseconds. Sounds dumb saying kiloseconds, but it's still true. 1,000 seconds could be called a kilosecond. It's the only one with a prefix, and that's just true. A kilogram is considered more useful, more practical base unit. So whereas we call these the SI units, meters is the SI unit. But of course, from that we get kilometers, micrometers, centimeters, millimeters. But M is the SI, kilogram is the SI. From that, more next week, we'll deal with mainly the top three. Area being length times width. So area of a rectangle, sure, length times width. And when we do that, it's like 5 meters times 6 meters. The answer will be 5, 6, 30, and then meters squared. Because an M times an M is an M squared. Volume, this length times this length times this length. Or length times width times breadth. Meters cubed. Like 1 meter times 1 meter times 1 meter is 1 by 1 by 1. It's 1 M cubed. So all of our areas will be units squared. All of our volumes will be units cubed. Velocity, we'll again look at that next week. But it's distance over time. We'll look at, a lot of you would have done the DST triangle. I'll bring it up again anyway. But even if we just think about speed in the car, I'm going at this many kilometres per hour. That's telling you speed equals kilometres, a distance, per means over, hour is time. Density equals mass on volume, not expected to know it. It might be told to you, like an exam question might say, given that density is equal to mass on volume, calculate this. So we can do that. It's just the first three we expect. You know what an area is, a volume is, and you can calculate a velocity. So various units of measurement, as we said, we form stuff. Kilo is combined with metre, form kilometre. Milli is combined with gram to form milligram. Okay? Very common stuff. But we want to get into what kilo and milli represent. And note, this isn't some law that we're going to be testing on. This is just a bit of common sense. If you got an answer of 245 million milligrams, instead of saying 245 million of these tiny things, well, we'd go further. We'd say, well, it's 245,000 grams or 245 kilograms. All this statement's saying is, don't leave like huge numbers. 245 kilos is good, okay? But no, for a question with us, it would say, express your answer in kilograms. If it didn't, and you wrote this, you're right. It's not incorrect. It's just common sense tells you there's a nicer way to write this. I'd rather visualize 245 kilos and say, oh, about a quarter of a car than 245 million micrograms. Yep. And again, there's another one. That many microliters. I mean, a microliter, probably even hard to see with the naked eye. 1230 mils, 1.23 litres. Okay, so we'll look at how those conversions are done. Here with millimetres, so let's intro, milli is 1,000th. So there's 1,000 millimetres in a metre. So if I've got 8,600,000 millimetres, well, we'll have a technique for this next week. But if 1,000 millimetres is a metre, it'll be the same as 8,600 metres. And if 1,000 metres is a kilometre, it'll be 8.6 kilometres. So again, techniques for that might be common sense to you, it might not be. You'll have the calc anyway, going times by 1,000 on the calc, whatever. We're not without the calc again. There might be questions, or there will be questions in the final exam, maybe something like from then. Do this fraction question without a calculator, show you're working. Okay, but you've got your calc with you. All right, so you can still check it. So here's, well, the bulk of the table. You'll know in your notes there's still more to the side. By the way, I know there's not enough time really to get the roll around at the end. I'll just put the visualizer on and just go through each name, get everyone going, yep, yep, yep. We'll sign the roll really quick, okay? It'll be slick. I think it's better when we've got this many in a room. I'll do the roll on the visualizer. We'll see how it works anyway. You don't have to know all of these, okay? Between mega and micro, Yes. But let's look at them anyway. Kilobyte. Well, maybe it's pretty small now, but when I say base unit, that's like base unit means something that doesn't have a prefix. It has got no, like byte, and then kilobyte, megabyte, gigabyte, terabyte. That's pretty much normal speak now. Do we know 1,000 gigabytes in a terabyte, or 1,000 meg in a gig, 1,000 kilobytes in a megabyte, 1,000 bytes in a kilobyte? Now, and that's, well, unfortunately in bytes, that's not 100% accurate. If you're a computer person and know that it's all in powers of 2, just ignore that at the moment. In terms of this, these are all leaps of 1,000, okay? So 1,000 grams will give a kilogram. 1,000 kilograms will give a megagram. A megagram sounds pretty dodgy. It's not, but what would we normally call a megagram? A ton. Okay, 1,000 kilos is a ton. In Australia, we call it a ton. In the SI system, we call it a ton, but a megagram is correct. A gigagram, a teragram, they're all correct statements, okay? And all of these ones down underneath, they're all leaps of 1,000 as well. There's 1,000 milligrams in a gram, or there's 1,000 micrograms in a milligram. So every leap on that table, while I put them all together, is leaps of 1,000. And notice up the side, to the 12, 10 to the 9, 10 to the 6, 10 to the 3, 10 to the 0. They're all jumps of 3. Yeah, they've all got 3 extra zeros on them. The higher you go on the table, you've got 3 more zeros. By 10 to the 3, that's 1,000. And also remember this notation. 10 to the minus 3, remember it's not a negative number, the minus meant 1 over. Meant 1 over 10 cubed. Drawing on the screen. It's 1 over 10 cubed, which is 1 on 1,000. So don't be put off by 10 to the minus 9, thinking, what the hell's that? It's 1 over 10 to the 9. Remember also your scientific notation. 10 to the minus 9, a negative power meant that's a real small number. Yeah, it is. It's a tiny number. 0.000000001. If it's got a positive power, it's a big number. So it's still the same as what we've learned in the first 3 weeks. So I didn't mention these. After beyond milli and down to micro, then there's nano and pico. But again, it's the mega through to micro we need. To the side, there's some ones that just are used in science, rarely used in day-to-day. Hecto becomes hectare, but hecto means 100 and deca means 10. On the downside of that, deci means a tenth and centi means 100th. It's all come from Latin. Out of them, there's the need to knows, okay? Centi, we assume you're cool with, that's 100th, like centi being century, because a centimetre is 100th of a metre. There's a centimetre, there's a metre. So we assume you're fine with centi and micro up to mega. If we were ever going to ask a question with a hecto or a deca or a deci, etc., we're going to tell you what it is, okay? I've got a question, I haven't got the notes that you'll see. This is the way it would come. But, yeah, just note the things we're expected to know. So, further on from that, some other conversions that we consider that we'll know. Like length, 10 millimetres in a centimetre. Okay, we're assuming. 100 centimetres in a metre, 1,000 millimetres is a metre, and 1,000 metres in a kilometre. So hopefully all of them are things you will have used somewhere before. Same with the masses, 1,000 grams in a kilogram, 1,000 kilograms becomes the tonne. And in time, yeah, we're aware, 60 seconds in a minute, 60 minutes in an hour. The other common one we'll use, how many seconds are in an hour? Because it's 60 lots of 60. So we've got 60 by 60 becomes 3,600. That'll be another common one we'll use next week. We'll just do a shortcut, say 60 times 60, 3,600 seconds, 1 hour. These may be not quite so definite that you know. Maybe you do, maybe you don't. 1,000 mils equals a litre? Hopefully, yep. You know, we've dealt with 375 mils in a can of Coke, but maybe 1.25 litres in the bottle. 1,000 litres being a kilolitre? Well, you know, it's just kilo, literally meaning 1,000 again. 1 centimetre cubed equaling a mil, we brought it up before. Maybe that's something you're aware of. But, yeah, It doesn't matter what the substance is. A volume of 1 centimetre cubed is a volume of 1 millilitre. So when you're talking about volumes, when you make a volume out of side by side by side, your answer will be in centimetres cubed or metres cubed or something like that. But sometimes the question might be asking, how many litres do I need to fill this pool? And these are the dimensions of the pool. So we need to be able to convert between maybe the pool holds 20 metres cubed volume. And someone says, well, how many litres of water can I fit in that? We need to know something like this one. If I've got a 20 metre cube pool, and someone's asking me how much water do I need, well, for every 1 metre cubed, I need to put in 1,000 litres because they're equal. So 20 metres cubed will need 20,000 litres. So picture that, a metre cubed, roughly that by that by that. So it's a fair size. There's 1,000 litres in that. Got a picture here. So there's my little 1 by 1 by 1. That's a mil. 1 millilitre sitting there. This one, it's more used in chemistry, but that's just a picture, a 10 centimetre by 10 centimetre. There it is. Well, 10 by 10 by 10. That's going to be 1 with 3 zeros on it. 10 by 10 by 10, that's 1,000 centimetres cubed, which is 1,000 mils, which is 1 litre. So visualising 1 litre, it's a 10 centimetre by 10 centimetre by 10 cube. So there's a litre. This actually is called, actually I won't even go there. No, I will go there. Not essential. That's called 1 decimetre cubed, okay? Because a decimetre is 1/10 of a metre. In other words, 10 centimetres is 1/10 of a metre. That's 1 decimetre. Not on any of our rulers, but this picture is the same as 1 decimetre. If I get 1 decimetre by 1 decimetre by 1 decimetre, I've got 1 decimetre cubed. So 1 decimetre cubed is a litre. You'll see that in a lot of conversion tables. I don't really focus on it because a decimetre is just, it might be 10 centimetres, but it's not common to us. The things I memorise are definitely 1 centimetre cubed equals 1 mil. And the next picture. That's not quite a cube, but that's about 1,000 litres. Once again, but imagine that's purely 1 metre cube. Well, that is 1,000 litres, or 1 kilolitre. Okay? So they're the things that we're going to need for next week to do these conversions. So if we get in the concepts, 1,000 litres fits in that. Rightio. The next bit are areas. Now, we've got 10,000 centimetres squared equaling a metre squared. This area thing, and it says on the notes, and it says down here, so I'm going to talk about it, explain it next week, but I'll just give it a quick check here. Why would a hectare be defined as 10,000 metres squared? Here it is here. You'll still hear acres talked about, just like a farmer talking about the size of his land might be so many acres. Nowadays, we should be talking hectares. And the standard unit for a block of land, 100 metres by 100 metres. Okay? That was defined as a hectare. So a hectare, 1 HA, is short for hectare, was just, you can see it's come from a hectometre by a hectometre. Hectare is 100. So 1 hectometre by a hectometre is a hectare. And there it is. So if I get 100 and times it by 100, I end up with 4 zeros. So 100 metres times 100 metres is 10,000 metres squared. That's why. That's why suddenly we've got this 10,000 metres squared sitting there, 100 by 100. It's nice and easy. And yeah, the other we'll go into next week. So there's our intro to our units, the things we expect, and that will be led on with next week. As for this week's examinable content, okay, we've got to do a bit of unit comparison. And here we're just going to do it by looking at, this is just a way to understand how big's kilo compared to milli? How big's mega compared to no prefix at all? Just being able to check these things. With a question, how many millilitres in a kilolitre? You might already know it, okay? You might know 1,000 mils make a litre. 1,000 litres make a kilolitre. So there's one way to look at it. If I just get in a kilolitre, so if I've got 1 mil, 1,000 mils So times 1,000 makes a litre. And then times 1,000 again, I get 1 kilolitre. So there's 1 million mils in a kilolitre. Okay, 1,000 in the first bit, 1,000 in the next bit, so 1,000 times 1,000, it's a million. The technique shown here is using these, using indices, but don't get put off by it. It can be a good method to use. If we're seeing how many of these things are in a kilolitre, first thing I'd like to do is just work out, is it a big number or a small number? Milli's small, kilo's big. So how many small things in a big thing? A lot. It's a big number. Okay. We're asking how many millis fit in a kilolitre. So I'm going to get kilo and divide it by milli. Kilo is 10 to the 3, in other words, 1,000. This from the table form. Milli is 10 to the minus 3, in other words, only 1,000th. And I'm saying how many of these are in this. So I get the kilo, the big thing, and divide it by the little thing. Arrhenius' laws tells us if we're dividing with the same base, we just subtract the powers. 10 to the 3 divided by 10 to the minus 3 is 10 to the 3 minus minus 3. Do a subtraction. 3 minus minus 3. 3 minus minus 3, that's 3 plus 3. It's 10 to the 6. 10 to the 6 is a million. So remember, before I did it, it was 1,000 times 1,000. That was a million. 10 to the 6, doesn't matter. 10 to the 6 and a million, both answer the same. It doesn't matter which way you write it. So we've got 10 to the 6 mils in a kilolitre. This is the one I stuck in just to say, if you're asking a question, how might we word it? Given that giga represents 10 to the 9, again, we don't expect you to know that. We just give it to you in the question. Given that giga represents 10 to the 9, how many kilolitres are in a gigalitre? So we give you giga, but we don't give you kilo. So we only expect between those limits that we said. So I'm saying, how many kilo is 10 to the 3? I'm saying how many 10 to the 3s are in 10 to the 9? So I'm going to get my large one, 10 to the 9, and divide it by 10 to the 3. That'd be 10 to the what? 6. 9 minus 3 is 6. So my answer again is a million. There are a million kiloliters in a gigalitre. And again, I'm thinking, yeah, if I get a kilolitre times 1,000 makes a megalitre times 1,000 makes a gigalitre. Yeah, it was 2 leaps of 1,000. 1,000 by 1,000, a million. So there's the wording of it. So now it's just the last 3 pages where we've got a lot of repetition. And I'll start doing little shortcuts and you'll see this isn't all about writing out all these indices. There's a bit of a shortcut to this. I've split this. Talked to a few people after yesterday's lecture and they didn't like the table and the notes with everything there. It's still whatever, but I've just split it. In the top one, I've left them in leaps of 1,000. In the bottom one, well, that's the leftovers. Okay, the hecto, deci, deca, centi. And we'll see if this table is any better. How many grams in a kilogram? What is it anyway? It's 1,000. Okay, if I was to use the table, I'd be saying grams in a kilogram. So the kilogram is 10 to the 3, and I'm wondering how many grams are in it. Grams is the base unit. It's got no prefix. It's 10 to the 0. 3 minus 0, yeah, the answer was 10 to the 3. So hopefully we know it anyway, but this method works. How many milligrams in a kilogram? Anyone know it anyway? Go from milli to gram, then to kilogram. It's 2 leaps of 1,000. Well, it's going to be 2 leaps of 1,000, so 1,000,000, otherwise known as a million. Yeah. So it is a million. 1, 2, 3, 4, 5, 6. But the kilogram, I'm saying how many milligrams in the kilogram. Kilo means 10 to the 3, and I'm dividing it by the small thing, which is 10 to the minus 3. So there you see me getting a 3 minus minus 3. 3 minus minus 3 is 3 plus 3. Nano in a kilo. All right, in a kilo. Kilo is 10 to the 3. Nano, if this is a question in our course, it'll be given to you as nano is this one, 10 to the minus 9. What's the answer to that? 10 to the 12. Let's just start looking at a shortcut there. Nanogram is tiny, kilogram is big. our answer is going to be huge. How many tiny things in a huge thing? Lots. Look at the gap between nano and kilo. Here's kilo, here's nano. And just look at how many steps would you need to take to get between that 3 and the -9. I'd have to take 3 steps to get back to 0 and another 9 steps to get to -9, 12 steps. It's 10 to the 12. If you look at the gap between the numbers, that tells you it's 10 to the something. Is it plus or minus? It's 12 because it's a big number. Okay, I knew it was going to be a huge answer, so it's not 10 to the -12, it's 10 to the 12. Again, well, kilograms in a gram. Do you expect a big answer or a small answer? Small. This is the opposite. We're saying how many kilograms in this gram. Okay? It's going to be a fraction. I'm not getting lots of big things and a little thing. I'm getting a fraction. So, kilograms in a gram. A gram is this one here. No prefix. A gram is 10 to the 0. Divided by kilograms is 10 to the 3. What's my answer? 10 to the what? It's that number minus that number. 0 minus 3? Yeah, it's 10 to the -3, which is the same as 1 over 10 to the 3. There's 1,000th of a kilogram in a gram. There it is. It's exactly that. 1,000th of a kilogram is a gram. Kilograms in a milligram do the same thing. In a milligram, it means, okay, the milligram's the thing I'm starting with. Milli is 10 to the -3. Divided by kilo is 10 to the 3. -3 minus 3 is -6. The minus just means 1 over, and 10 to the 6, it's got 6 zeros. There's a millionth of a kilogram in a milligram because there's a million milligrams in a kilogram. Okay, so the direction thing's important. And again, kilogram and milli. Kilogram was here. Milli, here. So the difference between 3 and -3 was 6. I knew it was a small answer. It was 10 to the -6. Okay, more repetition. Big or small answer? Small answer. Kilogram is big, microgram is small. I expect a small answer. A micro, I look at, is 10 to the -6. What's kilo? 10 to the 3. What's -6 minus 3? -9. Yep, that's pretty small. That's 1 on 1,000 million. Again, that answer's fine. 1 on 10 to the 9 is fine. 1 on 1 with 9 zeros is fine. Big or small answer? Big. Nanoliters are tiny. Megaliters are huge. So in a megaliter, mega is 10 to the 6. Nano, 10 to the -9. So what is it? 15. And again, this whole big small thing, if you use this method, you don't need to think about whether it's big or small, because it does it for you. Okay? But if you want to check your answer and say, oh, did that make sense? Did I do it the right way around? I expected a big number, I got it. Okay? So it's a bit of a check. Again, I would expect this one to be huge. Not quite as huge as the last one. The last one is mega. This one's only kilo. What do you reckon the answer will be? It's 1,000 times less. In other words, 10 to the 3 less. It's going to be 3 off the power. It'll be 10 to the 12. Let's check. A kiloliter is 10 to the 3. Divided by nano is 10 to the -9. There it is, 3 minus 9. 3 plus 9. Okay? It was a factor of 1,000 different. Micrometers in a kilometre. Kilometre, well, kilo again. The fact that it's meters, who cares? We could use any measurement you want. But we're talking about the prefix. Kilo is 10 to the 3, divided by a micro of 10 to the -6. So 3 minus -6 is 3 plus 6. We got a 10 to the 9. And here's the extreme one. Pico is the tiniest. I mean, this table goes on in both ways. We're just looking at it this far. Teralitre is 10 to the 12. We're asking it how many picos, which is 10 to the minus 12. What's that going to be? 10 to the 24. Centimetres in a metre. We know it in 100. But just confirming this method, in a metre has no prefix, so it's 10 to the 0. Centi has a prefix of 10 to the minus 2. And it looks odd, but what's 0 minus minus 2? It's 2. 0 minus minus 2 is 0 plus 2. My answer is 10 to the 2, which is 100. So even on these it works. Decilitres in a centilitre. My centi is a 10 to the minus 2. My deci is a 10 to the minus 1. Again, we've got to be careful with our plus and minuses. What's minus 2 minus minus 1? In other words, minus 2 plus 1, minus 1. Yep. Oops. Got to write the 10. And that's the same as a tenth. Either answer's good. Deca in a hecto. Well, hecto was 10 to the 2. And deca was the higher one. 10 to the 2 divided by 10 to the 1. 2 minus 1. It's just 10 to the 1, or 10. And centi in a kilo. Kilo was 10 to the 3. Centi was 10 to the minus 2. So what's my final answer? 5. 3 minus minus 2, 5. Okay, that's the content. Now we're just going to see if it works. Doing a speed roll. Patrick's not here, okay.